This conference will now be recorded.
Hello everyone. So today we will be talking about data types. So as I told you yesterday, whenever I am talking about the data types, so we have first of all, what is a data type? Data type is nothing but which will tell you about the type of the data. So what data type will tell you? So it will convey the type of the data. So what it will do? It will convey the type of the data. Okay, so now data types are put into two categories. When I say data types, so we have the data types into two categories. Okay, so let me write that point also. Data types in Python are categorized into two types. So data types in Python are categorized into two types. Single valued data types and multi-valued data types. Single valued data types and multi-valued data types. So whenever I'm talking about data types, so we have single valued data types and multi-valued data types. Okay, so single valued data types means again you put them into different categories. So first, numeric category. So first we put into numeric category. So under the numeric category you have int, so you have float, and you have complex. So these are the three categories of numeric. Okay, so numeric category. So under numeric category you have int, you have float, and you have complex. Okay. Second one is going to be Boolean category. Okay. Second one is going to be Boolean category. So under Boolean category you have only one, which is bool. Okay, so bool. So numeric category. So under the numeric category you have int, float, and complex. Okay, so under the Boolean category you have only one, which is bool. Okay, then we also have the none type category. None type category. So in which you have only none type. So this is none type category. Okay. Right. So under the multi-value data types, the first one is going to be sequence. Sequence category. Sequence category. So under the sequence category, you will look at str, you will have list, you will have tuple. So we'll go clearly with each and everything, and we have range. Okay. So these are the four. Then if you go for the second one, you have the binary category. So under the binary category, so you have bytes and you have byte array. So byte and byte array. Okay, so bytes and byte array. So you have these two, right? Then we will talk about set category. So under the set category, you have set and frozen set. So set and frozen set. So these are the two categories under set. So set and frozen set. So when I'm talking about set, so set is nothing but a collection of, okay, so collection of elements without duplicates. So this will contain duplicates. Okay, so that is what the major difference. Then we will talk about map category. So under the map category, you will look at DICT, which is nothing but dictionary. Okay, so dictionary we have. So single value data types, multi-value data types. So single value data types, numeric, int, and int, float, and complex. So first we will go into the understanding of. So we'll go into the understanding of the numeric category. Okay, so first we'll understand numeric category. So then we will talk about the other ones. Okay. So under the numeric category, as I have told you, you have int, float, complex. So when I'm saying int, so int will represent all the integer type data. So what int will represent here? It represent all the integer type data. Integer type data. So all the integer type data. So integer type data, as I've told you, so you have something like 80, 58 minus 90 and 987, and you have something like 0. Okay, and you have something like 36. Okay, so all this will represent integers. So there are many more, but just there are infinite numbers that we can have. So all these values are represented by int. Okay, so represented by int. Now how I can create an integer data type value? So simply what I can say is, if I say, if I say something like x1. So what is x1 here? X1 is a variable. So what is x1 here? X1 is a variable which will get a value. So x1 is equal to 89. So x1 is equal to 89. So what is x1 here? x1 is a variable. 89 is a data value. 89 is stored in x1. So what type of data is stored in x1? The x1 is storing int type of data and size is 1. So when I'm saying size is 1, as I told you, it is a single value. So single value in the sense it can be any big value. Now, for example, if I'm saying x2 is equal to, if I'm saying it is some bigger value also, that is also is single valued only. So all this is a single value. So never think that if you have number of two digits, like 2 digit, 3 digit, the values may I mean the values may increase, something like that. No, so it is not like that. Okay, so it may be 89, it may be 0, it may be 1. So it is all single valued only. So it is all single valued only. So in this way we create the so in this way we create the integer type of data. So integer type of data. So when I'm talking about integer type of data, so this is the way that we are going to declare. Okay, so this is declaration, and this is declaration, and this is going to be the values that are created. Now whenever you use x1, 89 will be used. Whenever you use x2, 1025 will be used. So the basic idea is to have the data values. Okay, so to have the data values. So this is the way that we are looking at the data. Okay, so this is called as the numeric category. Okay, so numeric category int. Okay, now when I want an integer, so you can just give a integer. So what basically is an integer according to us? Integer is nothing but a value which does not have a decimal point. So there is no decimal point over here. Okay, so if there is a decimal point, it becomes float. It becomes float. Okay, so float. So what is float here? Float is a representation of, okay, so it represents, so float is a representation of all float type data. So it is a representation of all, it represent all the float type of data, all the float type of data. So what float will represent? Float will represent all float type of data. So what do I mean by float type of data here? So float type of data in the sense we are having the float values. Okay, so we are having the float values. So what do I mean by the float values? Basically, float values are nothing but, so float values are nothing but the values. Okay, so float values are nothing but the values which will have decimal point, which will have decimal point. So float values are nothing but the values which will have the decimal point. Okay, so now for example, if I'm saying x3 is equal to, so 56.98. So what is this 56.98 here? So 56.98 is nothing but a value that has a decimal point. Okay, that has a decimal point. And if you look at this, this also is a single value only. So this also is a single value. So if you see size 1, it is a single value. Okay, if you see size 1, it is definitely a single value. Okay, so if you look at the size is equal to 1, so definitely it is going to be a single value. Now if I have to tell you example, so it can be 0.25, it can be 65.10, okay, 104. So if it can be a minus value also. Okay, so otherwise I can say 0 point. All these are float values only. All these are float values. Okay, right. So now if I am declaring this, so you get a float value. So you get a float value. So what is a float value over here? So float value is nothing but a value. Okay, sorry. So float value is nothing but a value. So which will have x3 is equal to 56.98. Okay, so x3 is equal to 56.98. Okay, so in this way you are looking at the float based value. So float, and it is a single value. So if it is integer also, it is a single value. So if it is a float also, it is a single value. So represent that. Okay, right. So next, coming to the complex. When I am saying complex, as you know, complex value will be a value which will represent the complex values, complex type of data. So it represents the complex type of data. So what a complex data will represent? It will represent the complex type of data. So what do I mean by complex type of data? First of all, complex type of data is nothing but the data which is going to be something like 3 minus 2j. Okay, so 3 minus 2j. So what is 3 minus 2j? Okay, so 3 minus 2j. So 3 is the real part and 2j is the imaginary part. Okay, so this is again a single value only. So it can be something like minus 8 plus 5j. Okay, so like this we can have any number of values. Okay, so if I have to declare this, I'll simply say x4 equal to, so x4 equal to 3 minus 8j. Okay, so 3 minus 8j, so 3 minus 8j. So what is this? This is a complex value. Okay, so this is a complex value. So whenever I'm saying complex, so complex means the value which is going to be, okay, so which is going to be uh, okay, so x4 is equal to, okay, so x4 is equal to 3 minus 8j. Okay, so x1 is equal to 3 minus 8j. So what exactly we are talking about here? So we are talking about a complex value. Okay, so complex value. So these are the numeric category. Okay, so when you represent integer, it is int type. When you represent float type of data, it is float type. When you represent complex, it is complex data values. Okay, so in this way you are going to represent the values. Okay, now so when I'm talking about this, so we are dealing with, okay, so what we are dealing with, we are dealing with the numeric data. So we are dealing with the numeric data. Now the next very important thing is conversions into int and floats. Conversions into int and float. So complex not very important, that's why we can ignore complex. So when I'm talking about conversions into int and float, so I want to convert into int and float. Okay, so I want to convert into int and float. So converting anything into int and float. Okay, so in that way you can look at it. So first conversion, very important conversion, is into two floats. Into two float. So when I'm talking about into two float, so into two float, so into two floats, I'm converting into two float. I'm saying int value to be converted into float. Okay, right. So when I'm saying I want to convert into two float, so to convert an int value to a float value, we can use, to convert an int value to a float value, we can use the following function. We can use the following function. So what is the function? Function is float of, so float of, okay, so float of int value. So you can give, so into to float you are converting, right? So into to float, when you are converting, you have to use float of int value. So float of int value. So LOIT float, in the bracket you have to produce, you have to provide the int value. Okay, you have to provide the int value. So float of int value. Okay, right. So here again, when I'm trying to do this float of int value, so I am going for example. So example, so int to float. So example, so when I'm saying example, I'm looking at example here. So take one integer value first. So how to take an integer value? I want to take an integer value. Okay. So let's say I will take an integer value x1 is equal to 89. Okay. So x1 is equal to 89. Okay. So we took integer value. Now we have to convert that into x1 is equal to 89. So now I want to convert that into float. Say x2 is equal to float of x1. X2 is equal to float of x1. So x1 is equal to 89. X2 is equal to float of x1. Okay, so float of x1. So I am changing the value. Okay, so I'm changing the value of x1. Okay, I'm changing the value of x1. So float of x1, I'm changing the value of x1 into float. Okay, so I'm changing the value of x1 into float. Okay, so I'm changing the value of x1 into float. So what I'm doing here, I'm changing the value of x1 into float. Okay, so Now, what happens when I am talking about x2? x2 becomes float value of x1. So, literally what happens? You can see it has become 89.0. So what exactly happens in the background? Okay, so let's understand what happens exactly in the background. Okay, so here, as you can see, so you have x1. So what is x1 here? x1 is going to be 89. So now what is x2? So x2 is going to be, okay, so x1 is int, we have only the integer, but as x2 is going to be, so float of x1. So what is float of x1? Float of x1 is nothing but float of 89. When I'm saying float of 89, so it is going to be 89.0. So we have integer part, the decimal point, and the fractional part. Okay, so 89.0. So we are having 89.0. So the integer part here, decimal point here, and the fractional part. So this is the way that we are converting an int to float. Okay, so now if I am taking another example, let's say I will take something like x5 is equal to minus 77. Okay, xy is equal to minus 77, and I'll say x6 is equal to float of x5. So x6, you take the float value of x5, means what is the meaning here? So x5 is minus 77. Now you want to convert that into, so float of x5. So what is x5 basically? It is minus 77. So now what it is converted to? It is converted to minus 77.0. Minus 77.0. So minus 77.0. Okay, so this is integer part, this decimal point, and the fractional part. Okay, so same thing if you are trying, and if you are writing here x1 is equal to minus 77, x2 is equal to float of x1. Okay, so let's say x5, x6, and this is x5, and is also x5. Okay, so simply if I am running this, now you can see, okay, I should print x6, right? So print x6. So what is x6 now? x6 is minus 77.0. Okay, so minus 77.0. So how you are getting this? You are getting this because so you are trying to have, okay, so you are trying to have the things like this. Okay, so that's the way that you convert into to float. Okay, converting into to float. So next we will look at converting float to int. So float to int. Okay, so when you are converting float to int, so now you are converting float to int. So when I'm saying you are converting float, so you are converting a 3-point number into single point. Okay, so 3-part number into a single part. Okay, right, to convert a float value. So to convert a float value to an int value, to convert a float value to a int value. Okay, so I want to convert a float value into a int value. Okay, so we use int of float value. So int of float value. So you need to give the reverse now. So you need to give the reverse now. So what is reverse I'm saying? Reverse means I'm giving a float and I'm getting an integer. Okay, I'm getting an integer. So float I'm giving an integer. Okay, so in that way you can go for it. So now, so I will say x8 is equal to, suppose if I'm giving 56.96, 56.96, 56.96, now I'll say x9 is equal to int of x8, int of x8. So now I'm printing x9. So now I'm printing x9. So what exactly I got here? I got 56. I got 56. Okay. So when I'm saying 56, so I'm saying 56. Okay. So what is 56 here? 56. How I got 56? So I gave 56.96, but I got only 56. So what is x8? X8 is going to be, okay, so as you know here, x8 is going to be 56.96. Okay, now this is to be converted into int. So int of x8, int of x8 is nothing but 56.96. Okay, so when I'm saying 56.96 or x8, so I am going for 56. Okay, so basically integer part, decimal point, fractional part. So I am going and submitting and I will get x9. Okay, so x9. So what is x9 here? x9 is 56. x9 is 56. So what is 50? Why 56 here? Because I will get only the integer part. I'll get only the integer part. So I'm not going to get the other parts. I'm going to get only the integer part. Okay, so in that way you are going to look at the conversion. Okay, so int to float. Okay, so int to sorry, float to int. So float to int conversion. How we went for the other one? We went for the other one as int to float. So that is how you can go for it. Okay, and okay, now if at all one more example if I have to show you, I can go for x10 is equal to minus 745.36914, anything. So now I will say x11 is equal to int of x10. Okay, so now I'm going to convert this x10 into int. So simply I'll say print of x11. So print of x11. So print of x11. Again, if you see, it is nothing but the integer value. Okay, so it is nothing but the integer value. So how I am getting the integer value here? Because you are converting into integer. You are converting into integer. As you are converting that into integer, you are getting the result. Okay, so now if at all I can go for this also. So this is going to be minus 745 dot 36914, and you are converting this into integer part, decimal point, fractional part. So here it is minus 745. So in this way you are going to take this into consideration. Okay, so that's how you are looking at the thing. Okay, and one small note I will write here. So the note is going to be note. So what is this note? So the note is the above conversion is not rounding. The above conversion is not rounding. Okay, so the above conversion is not rounding. Rounding is entirely different. Okay, so not rounding. In Python, we have a specific round function. We have a specific round function. Okay, so the above conversion is not rounding. So in Python, we have a specific function for rounding. Okay, so rounding. So what is that function basically? So syntax is going to be round of value. So round of value. Okay, so round of value. So how can I give that? Now let's say I will give something like round of 56.93. Now if you observe, we are going to get 57. How you are going to get 57 here? So you are going to get 57. So you are going to get 57 here. So you are going to get 57 by looking at. So what you did here, you said 56.93. So it will check the next integer after the point. So it will check the next integer after the point, and it will, if it is greater than or equal to 5, if it is greater than or equal to 5, next integer will be given. Next integer will be given. So what is the next integer? Next integer is going to be 57. Okay. Suppose if you have a value less than 5, if you have a value less than 5, okay, so 56.43. So now what you observe here, so you observe we are going to get 56. So you are going to get 56. Okay, so this is what it is, and the next one is going to be, okay, so the next one is going to be here, this one. So in this, what you observe, so in this we observe again 56.93. Okay, so what it looks at here, 56.43, sorry, so 56.43. Now this is less than or equal to 5. Okay, so if it is less than or equal to 5, if, okay, I should not use equal to now. If it is less than 5, if less than 5, so what you have to do is, so you have to give the previous integer. So what is previous integer? Previous integer is nothing but 56. So that is why you are getting the answers something like this. Okay, so 56 you are getting. So previous one 56.93. Okay, now sometimes you want to do uh, you want to specify number of decimal points. Okay, so point 967842. Okay, now you want to round off to the nearest decimal. Okay, so round off the nearest decimal. Now for example you want to make it 2. So now what happens here? So what we observe here, okay, so we'll just look at it. So now rounding is also very important. So here when you are rounding it, so what is happening over here? So you can see 985.967842. So when you are rounding it, so what it checks basically, so it checks the second digit. So second digit, what is the second digit? Second digit is 6, so it is greater than or equal to 5. So what will happen? So it will give you the next integer. What is the next integer? 7. Okay, don't think that this one. Okay, so this is not the case. So we are talking about, okay, otherwise I'll just remove the confusion. So I will say 2. Okay, so same answer will get. Okay, one second. Yeah, same answer means I'll get 96. So why I'm getting 96, I'll tell you. Okay, so let me go for this. Okay, so why you are getting 96? So here I'm having 2. Okay, so 2. So 962842. Okay, so now second digit. Okay, so it has to be within this range. So it has to be within this range. Now it will check the next digit. So what is the next digit here? So next digit is going to be less than or equal to less than 5. If it is less than 5, it will remain the same. Means you'll get 98.985.96. Okay. So in the previous case, what happened? So in the previous case, if you observe, so here you are having, okay, same number. So same number, and you have to 967842. So and you have to round it off. Okay, so you have to round it off to the 2 nearest, and look at this digit. This digit is greater than or equal to 5. So what happens if it is greater than or equal to 5? So it is going to be 985.97. Okay, so this one should be increased. This one should be increased. Okay, so in that way you are looking at, so in that way you are looking at the things. Okay, so that's how you deal with the things. Okay, so that's the way that you are going with the things, right? So this is rounding. Okay, so this is rounding. Okay, right. So then you have the next category, which is boolean category. So under the boolean category, you have only bool, the representation of Boolean values. The representation of Boolean values. So Boolean category means it is a representation of the Boolean values. Okay, so it is a representation of Boolean values. Okay, so it is a representation of which values? Representation of Boolean values. Okay, so bool. Okay, so we have bool. Okay, right. So now again, uh, bool means Boolean values means only true or false. So Boolean values means only that is true or false, or I should say true and false, both. Okay, so both means true and false, right? Okay, now I will say x7, okay, x12 is equal to true. So I'll say true. So what is true here? So true is going to be, so true is going to be what? So true is going to be a value. Okay, so in this way you are looking at a true value. Okay, so true value. So here x12 is equal to true. Okay, so x1 is equal to true. So in this way you are looking at x12 which is going to be a true value. Okay, so it is going to be a true value, right? Okay, then the same thing if you have false also. So suppose if I'm saying x13 is equal to false, so x13 is equal to false, so that is also bool. Okay, so in that way you are looking at true and false. So true and false. So when you are saying true, when you are saying false, so x13 is equal to false. Okay, so that's the way that you look at the data. Okay, right. So and finally we are looking at none type. So none type category. So under the none type category, so you have the data type none type. Okay, so it represents the none values. It represents the none values. So none values means I will say x15 is equal to none. X15 is equal to none. So as you can see here, this is none type object. Okay, so none type object. So none type object. So x1 is equal to none. Okay, so x15 is equal to none. Okay, so in this way we represent none. So there is a real use of none, so which we will be discussing later. Okay, right. So these are all about the numeric category and its conversions. So for boolean and none we don't require any conversions, but for these three we require conversions. I mean with these two, not complex also. So these are the things. So we'll talk about sequence category in our next session. Okay, thank you.